We are covering the essential fluid properties for the FE civil exam: density, specific weight, specific gravity, viscosity, surface tension, and the bulk modulus. You will find these definitions and associated fluid property tables in the Fluid Mechanics section of your NCEES FE Reference Handbook. Let's start with the three related concepts: density, specific weight, and specific gravity. Density, represented by ρ, is simply mass per unit volume. Its SI units are kilograms per cubic meter, and in US customary units, it's slugs per cubic foot. Specific weight, or gamma, is weight per unit volume. The key relationship to remember is that specific weight equals density times gravity, or gamma equals ρ times g. For water, the value you must know is 62.4 pounds per cubic foot, which is equivalent to 9,810 newtons per cubic meter. Specific gravity, or Sg, is a dimensionless ratio of a fluid's density to the density of water. An exam question might give you the specific gravity of oil as 0.85 and ask for its specific weight. You would simply multiply 0.85 by the specific weight of water, 62.4 pounds per cubic foot, to get your answer. The most common exam trap here is confusing mass density with specific weight. Always check your units. If you see pounds force or newtons, you are dealing with weight. If you see slugs or kilograms, you are dealing with mass. Next, we have viscosity. This property measures a fluid's resistance to shear. There are two types you must know for the exam: dynamic and kinematic viscosity. Dynamic viscosity, represented by μ, has units of Pascal seconds or pound seconds per square foot. Kinematic viscosity, represented by ν, is the dynamic viscosity divided by the fluid's density. Its units are meters squared per second or feet squared per second. Exam questions will test this by providing one type of viscosity when you need the other for a formula, such as calculating the Reynolds number. The Reynolds number can be expressed using either dynamic viscosity, where it's ρ Vd over μ, or kinematic viscosity, where it's Vd over nu. A classic trap is using the wrong viscosity. The symbol for kinematic viscosity, nu, looks a lot like a V for velocity, causing confusion. Your best defense is to always check the units given in the problem statement. If the units are length squared per time, it's kinematic. If they involve force, it's dynamic. Finally, let's briefly touch on surface tension and the bulk modulus. Surface tension, sigma, is a force per unit length, and it's what causes effects like capillary action. The FE handbook provides a formula for capillary rise in a tube, which is a straightforward plug-and-chug calculation if it appears on the exam. The bulk modulus of elasticity, K, measures a fluid's resistance to compression. It's defined as the negative change in pressure divided by the fractional change in volume. A high bulk modulus, like that of water, means the fluid is nearly incompressible, which is a core assumption in many FE civil fluid mechanics problems. You are unlikely to see complex problems on these, but you should be prepared to recognize the definitions and apply the basic formulas from the handbook. Here is a mnemonic to help you keep density and specific weight straight. Specific weight is weighty. It reminds you that gamma involves weight, which is a force that includes gravity, distinguishing it from mass density, ρ. Always remember, the FE exam is a test of fundamentals, and mastering these unit-sensitive properties is critical. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.